Aladdin Creations.
In the lab, we're set to go to test bacteria that we know. For glucose fermentation, they will try. Will they make acetylene? Let's find out why. Purpose is clear in the microbiology scene to differentiate organisms. The keen sheen to Turobacter serratia. They pass this test, but for E. coli, it's not the best. The Voges Proskauer give us the sign. Will a C-twin form align? Reagent swirl, red appears. That's how we know the result is clear. Positive is red as firelight. Negative stays yellow all night. This test gives us what we need. In microbiology, it's key indeed. Principle we're about to sing. Fermentation's the glucose thing. Some bacteria choose this way to make butanediol at the end of the day. First acetylene is the thing they make, then we add reagents, give it a shake. Diacetyl reacts to give a sign. When it turns red, it's test time to shine. Now let's talk applications. What's it for? To identify bacteria and more. Enterobacter or Klebsiella, you'll see they ferment glucose differently. Differentiating bacteria is the goal. Finding butanediol production in the role. For gram-negative rods, it's often used. In clinical labs, it's never refused. Here's the procedure, easy and clear. Inoculate the broth, we're almost near. Incubate for a day or two, then add reagents. Here's what you do. First a naphthalate goes in the brew, then potassium hydroxide, it's true. Shake it up, let it sit for a while. Watch for the red, and you'll smile. Voges Proskauer give us the sign. Will a C-twin form align? Reagents swirl, red appears. That's how we know the result is clear. Positive is red, we're on our way. Negative stays yellow all day. With this test, our work is done. Microbiology's so much fun.